We are going to do this exercise today, 11D.
Mhm.
This is all about integration with reverse chain rule. That's it.
Yeah.
Which one should I start with?
Um,
Let's do quickly one.
have we not done this exercise already? Looks
Sorry,
yeah.
have you?
No, nothing. Don't worry about it. Don't worry about
Okay, which one should I?
it. Did we not do this last? All right. Yeah. Let's start with one. 1D, I guess.
Okay. So here
Let's go
to
some wacky ones here.
integrate, he is asking to integrate this function e to the
hmm
power 2x divided by e to the power 2x whole squared.
hmm
This any idea?
I mean, so the derivative of the function is at the top,
Yeah.
so it should just be a half ln e to the x plus one. No.
No, no. Here we have exponent to it. So let's take it in the
Mhm.
numerator.
Oh yeah, yeah.
Now we have to see what is inside the power. This is general power rule, which I told you. Whenever we have
Mhm.
a power on a function, exponent on a function, and derivative of the function inside the exponent is available here.
Yeah.
Then the antiderivative simply add power to the add one to the power, add one to the exponent, and divide by new exponent. This is
Oh
called
yeah, yeah.
general power rule. This is called general
Mhm.
power rule, right?
I remember now. Yeah,
General power rule. So we are going to use this general power rule. We can also use substitution method, but that is in the next exercise.
yeah.
We can do it directly in this exercise. So what is the derivative of the function inside the exponent?
Just e to the 2x. Oh, no,
No, oh,
2 e
no,
to the
no.
2x, right?
2 is the power 2x. So 2 is missing. So we are going to divide by 2 outside and multiply by 2 inside.
hmm
So there the derivative is completely available like this.
hmm
Derivative is available. Now when derivative is
Yeah,
available, we are going to just use the general power rule. Add plus plus 1 to the power plus 1 to the exponent. This will be negative 1 and
mhm,
divide by negative 1 plus c.
yeah.
That's it. That's it. Just you need to simplify it further. Next,
hmm Um, Next let's do h.
E E is same, F is similar, also H. Let's do this to
Yeah.
the next page. Add to the, sorry. Let's solve it on the next page. To the new page.
hmm
Okay. So integrate. This is just similar. I mean, this is just similar to the previous one. Cos 2x, sin 2x whole power 4 divided by cos
Yeah.
2x. This is same. So the
hmm
function inside is 1 plus sin 2x, whose derivative is available here. What does it? What is the derivative of sin 2x?
Cos 2x. Oh no, 2 cos 2x. So,
2 is missing, so we will give 2, divide by 2
yeah.
outside and give 2 cos 2x. There, so
hmm
derivative is available now. We will just add 1 to the exponent and divide by the new exponent. So this will be
hmm
10 in the denominator. This will be 1 over 10 times 1 plus sin 2x power 5.
hmm
Clear?
Yeah. Okay.
Next,
Yeah, those are quite easy.
let's do this one. I
Okay.
add to the new page. Any idea?
Uh, if you
Sec square 10. Yeah, quickly.
you just do the tan the squared is just outside the tan and the oh wait no yeah wait the derivative of tan squared is sec squared, is it not?
Derivative of 10 is
So
10 is derivative of 10 is sec square. So we are gonna write it like this.
yeah
So derivative is available.
yeah so it's just a
Derivative
third
of
n
10
x
is
to the
sec
power
square
3.
x. Yeah, exactly. 10 2 x divided by 3. Simple. Plus c.
Hmm.
Clear? Next.
Yeah yeah
What about this one?
um
Add to the new page. What about this one?
uh is 1 plus tan squared x not just sec squared x?
Yes, it is sec square x, but this will not solve our problem. We cannot integrate
Oh,
sec
that's
power
true.
4, sec power 4x. This is difficult. So what you will do, you will
That's
multiply
true.
sec square inside. Multiply sec square inside
Oh,
will give us
interesting.
sec square x plus sec square x sin square x. So we will integrate this,
Hmm.
both terms. Antiderivative of sec square is 10x. And
Yeah
we just did this. This 10 cube x divided by 3. You are
yeah.
done.
Hmm.
Any questions?
No, that's all clear.
Give me a
So
second.
what's okay?
Just give me 1 second. Okay.
Yeah.
Hello. Yes, please. Which one now? Next.
I just want to ask. So, where does the reverse chain rule come into this? Because this is just what we've been doing, is it not?
Yes, this is reverse chain rule.
Okay, yeah. It just doesn't seem very different to what we've been doing this
Yeah,
whole time. It's just like,
let me explain that why this is a reverse chain rule.
hmm
Let's add. Let me explain it onto the new page. Uh, what happened? Okay. Let's add another page, and this is reverse chain rule. Let's talk about what is chain rule when we have a composite function f of g of x. This is a
hmm
composition of two functions, right? And if we want to compute the derivative of a composite function, how do you compute? You first of all take the derivative of the outer function, keeping inner function same, and you multiply the inner derivative of the inner function. This.
hmm
Okay,
yeah.
so if the derivative of composition of two functions is like this, so what should the antiderivative of the composition of this composition of the derivative with g of x? So we need g prime is here in order to integrate.
Oh
So
yeah, of
this
course.
should be for g of x. This is we are doing in every case. The derivative is present here. Derivative of the inner
Mm-hmm.
function. Derivative of inner function is present. We can simply integrate this like this.
Mm-hmm.
Is it clear?
Okay, I see. That makes sense. Yeah.
Which one next? All are
Um.
simple and easy. Which one?
Yeah. Uh. I mean, which ones look difficult to you? Maybe 2H looks complicated.
2h, 2h. Let's do
Yeah.
2h.
Yeah.
Okay. 2h is this one.
Mhm.
It's not complicated. It's also very easy. Add to the new page. Let's do it. Okay. How it looks complicated? Just take the root in the numerator. It will be x squared plus x plus 5 power negative 1 over 2.
Oh, oh yeah, and the derivative is just oh yeah, we don't have to do anything. Yeah, I see.
A add 1 to the power and 1 upon 2
Hmm.
minus 1 upon 2 plus 1 divide by minus 1 over 2 plus 1. That's it. So it will be
Okay, yeah.
root square root of x square plus x plus 5 divided by 1 over 2. So this is going to be 2 times plus 3. That's it.
Hmm. Okay. Are
Next.
there any hard ones?
Ah, yeah. Which one?
I
All are
don't. I
easy.
don't know. These all
All,
look quite.
which one?
Should we move on to before five? Yeah,
Sorry.
these are all quite easy. Is there? These all look like
Yes.
they're quite easy. Yeah, well,
All.
let's do six, and then maybe can we move on to a different exercise if these aren't even worth doing?
Let's do which exercise?
As
Should
in,
we go
should
to
we
next
move on to a
exercise?
different exercise if these are, or like if these are
Uh,
all like too easy? Then
let me tell you. Uh, what about this one? There are all
mm,
are not easy. All are not easy. Let's
okay,
talk about
so let's,
4, 5, and 6.
yeah,
You try this.
let's do
I want you to try this. If you see this is simple, how to prove this? Just do it.
it.
Hello.
All right,
Hmm.
yeah,
G.
integral
जी जी बता.
tan x equals n sec x.
None
See, okay,
none पर फारिग में था
so
कमा. अच्छा no.
we're gonna split this into
Okay.
sin x over cos x, and then the derivative of cos x. Okay, you're left with forget sin x times. Okay, well you have a minus out here, minus in here, and then times 1 over. Or this can just be what sec x. But do I have a thing for that? No. Um. So this is technically minus sin x times cos x to the power of -1.
Hmm.
Uh, oh, but that doesn't help me, does it? That doesn't get me towards ln sec x.
Hmm.
Uh, oh, but is it not just hang on? If I just go minus and then minus sine x over cos x, does that not just integrate to? It's the one where it's like f of x over f dash x equals ln f of x.
Yes, yes, yes.
Is that not a
You,
rule?
yes, yes. This is
Oh,
the
so
rule.
it's just
This is also same as reverse chain rule. When we have
yeah.
composition
So
of
this is
some
just the same
function,
as
yes, yes. When we have composition of some function with log of x, with logarithmic function, then we have a rule like this.
minus ln of cos x, which is the same as ln cos x to the power of -1, which is the same as ln sec x.
Exactly, exactly, exactly,
Damn.
exactly.
Too easy.
Yeah. Can you erase this?
Yeah, yeah.
So, okay, let's move to the next exercise. Let's move to the
Mm.
next exercise. Uh, so in the book. I only selected six I should for this lecture, but all the questions are very easy for you. So let's do not
Yeah.
waste your time and move ahead to solve the next exercises. Where we are, this was 11D, right?
Hmm.
So next is integration by substitution. So
Ooh.
this is also very easy. There's no any, I don't think
Yeah,
there
yeah.
is. Let's say to the new page. So
Hmm.
now that will take some time because there are 434 pages in this file.
Yeah.
No problem. That's whiteboard will refresh all pages again and again if we are adding to the next page. Okay, this
Mm.
one using substitutions. Now this is the same question which you can do directly as well. But how to do it with substitution? Substitution, why we are doing with substitution? Because substitution is the strong method. You cannot do it by, sorry, I'm sorry, you cannot do by direct method. This is not done by direct method. There are some
Hmm.
questions which in previous exercise we were doing directly by using reverse chain rule,
Hmm.
but these questions cannot be done directly. What do you have to do in these substitutions? You have to see which function is inside the exponent. The question is,
Hmm.
which function is inside the power, the exponent? This is the question. First question. Whenever you see questions like this, you have to see which one is inside the power. So you
Hmm.
will substitute that function equal to some other variable. Change the variable of integration. Let's take it y,
Hmm.
right? So
Yeah.
in these substitution methods, we usually take our integral equal to some variable. Say, let's say I. We usually take it equal to I. So
Uh-huh.
we suppose this integral is I. After substituting this, I will be what? So we can replace 2x plus 5 equal to y. What about x? X here. We are changing every x to y. So
Hmm.
will uh, uh, find x from this substitution. X will be y minus 5 divided by 2, right?
Hmm. Yeah.
So we will put x equal to y minus 5 divided by 2. And what about
Hmm.
the element of integration? This differential will also be replaced by dy. So we are changing everything to y. So replaced by dy, it should be replaced by some function of dy. So how is this is done?
Hmm.
From this substitution, we are going to differentiate both sides with respect to x. Differentiate with respect to x
Hmm.
will happen. What is the derivative of 2x? If we differentiate with respect to x, the derivative of 2x is 2, right?
Hmm.
What is the derivative of 5? Is no.
Hmm.
What is the derivative of y? Dy by dx. We don't
Hmm.
actually y is function of x, so its derivative will be dy by dx. So if we
Yeah.
determine dy from here, so dy will be equal to 2 times dx.
Mm.
So
I see.
we will put dx, sorry. So we will put dx equal to, yeah, dx equal to what?
Dy divided by 2.
Exactly
Yeah.
this. So now we will everything then y in terms of y, we can take 4 outside. 2 times 2 is 4. So 4 can be taken outside. Y minus 5 will be multiplied with the root of y, square root of y. So
Hmm.
let's multiply y power 1 upon 2 with each of the terms inside bracket. So y power 1 upon 2 multiplied by y power 1 will be y power 3 over 2. Y raised to 3 over 2, right?
Yeah.
Minus 5 times y 1 over 2.
Hmm.
We will simply take antiderivative of each of the terms separately. So antiderivative of y power 3 over 2 minus 5 times antiderivative of y power 1 over 2.
Hmm.
Like this. So y power 3 over 2 can be integrated by simple power rule. What it will be?
Mm-hmm. 5 over
5
2.
over 2 divided by 5 over minus 5
Mm-hmm.
times y power 3 over 2 divided by 3 over 2 plus.
I see. Okay.
So 2 will be cancelled
Huh.
with this 2 times. And we have substituted. Now we have to back substitute. Because our original integral contains x only,
Yeah.
there was no y. Y was introduced by us. So we need to
Mm-hmm.
replace y. So y was equal to, I think, 2x plus 5.
Mm-hmm.
So we will put it back into this expression. So integral antiderivative will be 1 over 10 times 2x plus 5 raised to power 5 over 2 minus 10 over 3 2x plus 5 raised to power 3 over 2. If you have any
Mm-hmm.
questions, please ask. This is done.
No, that makes sense. That makes sense. Okay. Got it.
We
Mm,
have, this is the answer here. It's same.
okay. Got it.
Is it same? There is some difference I see.
Um,
Ah, what is the problem? 2x plus 5. What is the problem? Why our answer is not matching with this expression?
no
Have we
idea.
done any mistake? What is the power here? Let's zoom it. Power 3 over 2. This is 5 over 6. What is our answer is
Mm,
10 over 3. Do we have anything wrong? We have done anything wrong. Oh, I'm really sorry. I missed this 4. This 4 was multiplied with each
no,
of the
so,
terms. So
mm,
I need to multiply it with this,
mm,
this term as well, right? So this was the mistake.
yeah, yeah.
I made this mistake. So let's correct this.
Mm-hmm.
So this is going to be uh 2 will be cancelled with this 4 and the answer should be 5 over 5 over 6. Okay.
So,
So there was some error made by me. Any questions?
no, no, that's fine.
So
I think
let's
I've got the
go to
method.
the.
Yeah.
Okay. You told me once that you are doing substitutions, a lot of substitutions. So probably you are doing this exercise. Let's
I've
do.
done a little bit, but
Use substitution to find this. Add to the new page.
mm,
Now he's telling us the substitution. You have substitutes 1 plus sin x equal to u.
mhm,
But you can identify which what should be the substitution yourself. So the idea was the point which I told you that you have to see what is inside the exponent. What inside the
mhm,
exponent? It is 1 plus sin x.
yeah.
So we will substitute 1 plus sin x equal to u, a new variable.
Mhm, yeah.
But we have cos x here and sin x here. So what we will do? We also need to substitute for these two functions and dx as well. So sin x can be determined from
Mm-hmm.
this substitution. Sin x will be equal u minus 1. Okay.
Yeah.
What
Mm-hmm.
about cos x? What about cos x now?
Well, when you work out du by dx, doesn't the cos x get cancelled?
Exactly, exactly. We will differentiate with respect to x both sides. What will happen? The derivative of 1 is 0, derivative of sin x cos x, and derivative of u will be du by dx. So when dx will be multiplied this side, so cos x dx will be equal to d. We'll make this substitution.
Mm-hmm.
Okay.
Yeah.
So now let's make this substitution into this integral. Okay. So I will be equal to sin x is equal to u minus 1. So we will put sin x equal to u minus 1. And 1 plus sin x equal to u. So this will be u power 3. Okay.
Mm-hmm. Yeah.
And cos x times dx is equal to du. So after making this
Uh-huh.
substitution, this will be equal to this. Now this has
Yeah.
become very simple. Very simple.
Mm-hmm.
Multiply u cube inside this bracket. So this will be u power 4 minus u power 3 over
Mm-hmm.
du. Now integrate each of the terms. Antiderivative of u raised to 4 will be u 5 divided by 5. And
Mm-hmm.
antiderivative of u cube will be u 4 divided by 4. So u,
Mm-hmm.
this is 4 plus c. Now one thing is remaining
Mm-hmm.
only, that is back substitution.
Mm-hmm.
Back substitution. U is equal
Yeah.
to 1 plus sin x. So we will
Mm-hmm.
replace u by 1 plus sin x. This will complete the solution. 1 plus sin x power 5 divided by 5 minus 1 plus 5 sin x over 4 divided by 4 plus c. That's it.
Mm-hmm.
Clear?
Nice. Got it.
Now let's move to the exercises. Let's move to the
Mm-hmm.
exercises, or should we do anything else?
Mm-hmm. That's something that
Should I
looks
explain this
difficult.
question? Should I do this question?
Yeah, yeah. Let's do it. Mm-hmm. Mm-hmm.
Add to the new page.
Oh, arc sine. Oh. I haven't seen a question like this before.
Uh, there are a lot of questions like this. Uh, when antiderivative comes in terms of the inverse trigonometric functions. So there are three cases actually. And this is called trigonometric substitution. Let me give you an idea.
Mm-hmm.
If you are integrating, let me give you a complete idea
Mm-hmm.
of these type of questions. Then you can solve many questions.
Yeah. Okay.
Okay. Integrand contains, if integrand contains these type of square roots, a
Mm-hmm.
squared minus x squared, where a is any number,
Mm-hmm.
right? In this
Yeah.
particular question, what is the value of a you see?
Just one. Yeah.
Yeah. So if integrand contains this, you have to substitute x equal to a sine theta. X equal to a sine theta. This is the rule. If your
Oh, really?
integrand yeah, if if your integrand contains the root of the same thing but in reverse order, x
Uh huh.
square comes first and then a square. Then the rule is you have to substitute x equal to a sec theta. And number
Uh-huh.
three rule is if your integrand contains the root of a square plus x square, there is
Uh-huh.
minus in 1 and 2, there is minus in between. But whenever there
Yeah.
is plus in between, then the substitution is x equal to a tan theta. This is very interesting.
Mhm. Okay.
There are reasons behind these substitutions. You will observe the reasons.
Mhm.
Let's observe the reasons. So in this particular
Yeah.
case, which question is given to us, what this question is similar to which one of these? One,
Mm.
two, or three?
Number one.
Number one. You said
Number
a
one.
is
Number one.
equal to you said a is equal to 1. So we are going to
Hmm.
substitute. I'm sorry, battery is low. I forgot to plug the charger. Substitute x equal to what?
That's okay.
X equal to
Hmm.
what?
Oh,
According,
just sine theta.
yes, just sine theta. 1 sine theta because a is 1. So just sine theta. Okay. So let's make this
Yeah.
substitution here, but we have to convert everything else also in terms of theta because our new variable is theta now. Theta is a variable here.
Uh,
So take theta as a variable, right?
um,
So we are going to
yeah.
differentiate with respect to x. Let's differentiate. So dx over d theta will be what? What is the derivative of, oh, sorry, with respect to theta?
Oh,
Let's differentiate with respect to theta. What is the derivative of sine theta with respect to theta? It will be,
cos theta. Yeah.
yeah, theta is a
Um,
variable. Theta is a variable.
yeah.
So derivative of sine theta with respect to cos theta will be, with respect to theta will be cos theta, na? Right?
Hmm. Yeah, yeah.
Right?
Okay.
So what we dx equal to?
Um, cos theta times d theta.
Exactly, cos theta times d theta. Let's make these replacements. Let's make these substitutions into the given integral. So your given integral will be I equal to what? Integral of square root of 1 minus what we are going to put x equal to sine
Oh,
theta.
sine theta. Okay.
So this will be sine square theta. What
Hmm.
about dx? Dx is equal to
Cos squared. No, cos theta.
cos theta d theta.
Okay.
Okay. What
Yeah.
about 1
Oh,
minus sine square theta?
oh, that's just cos squared theta. Oh, I
Exactly,
see.
because we
Okay.
know that sine square theta plus cos square theta is equal to 1. So 1 minus sine square
Mm,
theta will be cos square theta times cos theta d theta. So this will be
mm,
cancelled with this. So we left will be only 1. 1 d theta. What is the
yeah.
antiderivative of 1? What is the antiderivative of 1?
Is it cos theta in this case, or is it sine?
No, no. Antiderivative of 1 only.
Oh, sine. Yeah, sine theta.
No, no. What is
Sine
antiderivative of
theta
1? Whose
in this case,
derivative is
right?
1? Whose derivative is 1?
Oh,
What is,
x with respect to
yeah, x.
dx, but
This should be theta here.
oh, do you not? Oh, yeah. Oh, just theta. Okay.
Okay.
I
Because
see.
antiderivative
Okay.
of 1 with respect to theta should be theta. If it is with respect to x, it should be x.
Yeah, I see.
So the answer is theta, but
Yeah.
theta is introduced by us, so we have to
Mm.
make the back substitution. Let's see what is
Uh-huh.
our substitution. What was our substitution? What was our substitution? It
Uh,
was, eh,
1
it
equals
was this.
1 equals sine, no, x equals.
So theta will be equal to sine inverse x, or you can also write it as arc
I see.
sine x. Arc sine x. Okay.
Mm-hmm.
So we will make this big
Mm-hmm.
substitution here. Arc sine x. Let's see.
Mm, I see. Okay.
How was this? How was this?
That's interesting. Does it work with any number other than 1
Yeah, yeah. This will work with any number other than
in the
one. Let's
start?
do it again. Yeah, yeah. Let's do it again. I think the
But it
meeting will
has
end
to be a
in
square
few
number, right?
minutes.
A has to be. Oh yeah, yeah.
Let's reconnect this. I'm connecting my charger of the laptop. It will be
Okay.
an important connect. So the meeting will end in 1 or 2 minutes. Remaining meeting time is 3 minutes. So give me some time. I want to connect the charger for some
Okay.
for now. You can try this. Let's try this one. Square root of 4 minus x square. Try to solve this.
Mm-hmm.
You do it. I'm coming back.
All right. Okay. So with substitution you make is um. So you go.
No, you have to see what is a. What is a here? What is the value of a here?
Oh, A is 2, is it not?
Yeah, exactly. So substitution should be 2 sine theta.
Oh yeah, you're right. You're right. I forgot about that. X is 2 sine theta. Okay, so I forgot the fucking method, bro.
What are you saying?
X is 2 sine theta. So
Hello?
integral of 1 over root of 4 minus 2 sine theta sine squared theta, right? Oh wait, no, this is all squared, so it's
No.
4 sine theta,
हाँ
right?
चाहते हो अच्छा लो
4 sine.
हाँ 2 मिनट है
Um, huh. Which, if you take the 4 out, is the same as 1 over root
What about dx?
4 cos
What
squared
about
theta.
dx? What about dx? You have to change dx as well.
Oh yeah, dx. So hang on, d theta by dx. All right, I'm back.
Okay.
I was mostly getting it.
Yeah, yeah. Okay, you can continue from here. Dx will be 2 cos theta d theta. You can
Yeah.
simply differentiate with respect to. Now put everything into here and further simplify this. Let's see what happens.
Yeah. So you end up with integral of t cos theta over t cos theta, which equals 1 and then integral of 1 equals theta, and then from here you know that theta is the same as sine minus 1 x over 2, right?
Right.
Equals theta, so then this equals, well, this equals that, and then that's the answer, right? This.
Right.
All right.
Correct. Right.
I understand the method. I understand it.
Let's do one more question, and then we
Mhm.
will do exercise in the next class.
Yeah.
Okay. Let's do one more question like this. First of all, let's revise where were the substitutions which I told you. Uh, where were those substitutions? Gone. Ah, yeah, these substitutions.
Yeah. Yeah.
These three rules. Remember these
Mhm.
rules. If we have a function like this, then substitution is this. If substitution function like this, substitution is this. If we function like
Mhm.
this, then substitution is this. Let's do another similar question which belongs to the one of these three cases.
Mhm.
Okay. So let's do it here. So the question is we have to integrate uh let's do it simple. 1 over 4 sorry 1 over x squared minus 9. Yes. Let's do it. What
Mhm.
substitution should you do here? What is the
Uh,
substitution for this?
all right. 3 sec theta, right?
Exactly.
Mhm.
Uh suppose give me a second. Give me a second.
Yeah.
Hello. Suppose that we have x here as well.
An x up there
Okay.
as well. Oh.
Yeah.
Oh.
Doesn't matter. The substitution. Oh, sorry. No. Wait. Not here. This would become very easy otherwise. 1 over we have x here as well. Now let's do it.
Okay. So x equals
3 sec theta.
yeah.
3 sec theta.
Yep. Yep.
Okay.
Okay. Uh.
So dx will be equal to
Um. Sec. Wait.
what is the derivative of no, you should not write it like this. You shouldn't write it like this, please. You
Oh.
should
Okay.
you should, you should differentiate this with respect to theta. Just differentiate with respect to theta. What will happen? Dx by theta will be equal to
Oh yeah.
times
Yeah.
what is derivative of sec theta?
Not sec theta tan theta.
Yes. So you need
Yeah.
dx from here. So dx will equal
Oh
to
yeah. I got them the wrong way around.
tan
Yeah,
x
my bad.
theta and theta. Do like this. Now substitute.
Mhm. Um, yeah, let me just get this sorted out. Okay. So now that I've got that, x still equals 3 sec theta.
Yes.
So we have integral of 1 over 3 sec theta times the square root of 9 sec squared theta minus 9 all times 3 sec theta tan theta. What?
Yes.
Yeah. No. Yeah. All times
Hmm.
sec theta tan theta. Okay, so you end up with 1 over 3 sec theta times 3 sec theta minus 3, and
No,
then
no.
times all this, so
One,
you cancel this,
no, no.
and so you have,
Ni-
oh,
no,
do you
no.
not?
Damiano, listen to me. I can take common from here. How this comes out to be 3 sec theta minus 3. This should be 9 times, this should be 9 times sec square theta minus 1. If you take 9 outside. And the rule is there.
Yeah, but when you square root it, do you not?
You cannot take the square root. There are two terms inside. There are two terms inside. 9 sec square theta minus 1 will become like this.
Oh, I see, I see, I see. Okay.
Then sec theta
Um,
minus 1 is equal to what? Sec theta minus 1 is equal to what?
tan theta, no. Oh,
Yes. This is the second identity. Parallel
oh,
tan square theta to
I see.
square theta or tan square theta is
Yeah, yeah,
equal to
yeah,
sec
yeah, yeah.
square theta minus 1. So you will just put tan square
Oh,
there. So in the
that makes sense. That
denominator
makes sense.
we
That makes
will
sense.
have 3 theta and 3 tan theta. And in the numerator we have 3 sec
Mm.
theta tan theta. So 3 will be cancelled, sec
And so
theta
yeah,
will
so you'll cancel
cancel,
out.
tan theta will be cancelled, d theta will get. So we
I
only
see.
have 1 over 3 times integral of d. What is that? Theta plus 3.
Mm-hmm, mm-hmm, mm-hmm.
Now
I see. I see.
from the substitution you made from here only theta. Theta equal to
Oh, sorry.
sec inverse x over 3, right?
Mm-hmm.
So you just put it here. Theta equal to sec inverse x over 3 plus c. And we're done.
Oh, I see. I see. I see. Okay, that makes sense. Are you gonna send me these so I can have the rule and everything?
Unfortunately, I will try to send you, but this is the book now. I will try to send you. I will take, this is difficult for me to select particular
Maybe take like a
pages, but I will
screenshot of
try. I will.
like the most important.